My name is Zehra Özer. I am from Turkey. So I study Master in Statistics at Switzerland University of Bern. And I will present my research, which is called Quantifying DNS Resilience, a statistical framework for global internet infrastructure. Before we start, let me explain our main focus briefly. Why are we doing this? Today, we usually look at DNS only after a problem happens. But we want to look at DNS as a critical global infrastructure. Our main focus is to use statistics to measure DNS stability and see hidden risks before they become real failures. So next, let's start with how DNS works in our daily lives. DNS is like a invisible backbone of the internet. It translates domain names into IP addresses. Users do not see it because it works quietly in the background. On this slide, I want to show three important points. The first one is critical dependency. Today, all modern system needs DNS to work. But current tools are reactive. They only look at problems after they happen. Second one is strategic mission. ICANN works to keep internet secure and stable, as we know. To do this, we must find hidden risks before a crash happens. And the third one is the research gap. Actually, my question is, can we use statistical models to predict future failure risks and build a proactive resilience? After talking about the risks, let's look at what happens in the real world when DNS fails. This slide shows the famous Divine DNS outage. It shows that a single technical failure can create a massive global crisis. So this creates three big consequences. The first one is, of course, the system loss. Major platforms like Facebook, Instagram, YouTube become completely inaccessible. We cannot just watch the system, we must estimate the risks earlier. And the second one is economic impact. Outages cost billions of dollars. Monitoring tools can report the loss, but they cannot prevent the damage. And the last one is interconnectivity. Because the internet is connected everywhere, a small local error can become a global crisis very quickly. To prevent this global crisis, we need to understand that DNS is not just a simple one step. It is a chain. DNS is a big ecosystem chain, as I said, and we focus on three main components here. The first one is root servers, the starting point for every resolution process. And the second one is TLD servers. They direct queries to specific domains like .com or .org. And the recursive servers, they are like the librarians of the web because they find and catch, save the final answers. And if one link in this chain fails, the whole internet suffers. So we must measure the resilience of the whole chain, not just isolated servers. Now that we saw the chain, how can we measure it like engineers? Complex systems need a clear engineering pillars to stay stable. Our framework uses three main concepts. The first one is reliability. Actually, this is the most important one. The probability that a component works perfectly over time. We can calculate this using real statistical data that we got from the past. And the second one is fault tolerance. The system's power to continue working even during a local crash. And the last one is redundancy. Having backup servant nodes and statistic can help us find the optimum number of backups that we need. So from this engineering concepts, we can use a specific and really special mathematical model for DNS redundancy. DNS is designed to avoid single points of failure. To calculate this, actually, we can use K out of N model. Let's look at the symbols of the slide. N is the total number of available server nodes, and K is the minimum number of active nodes we need to keep the system running, and R is the reliability of a single node. So actually, the logic is really simple. This system stays alive as long as at least K out of N nodes are working correctly. This buffers project protects the internet against traffic surges and, of course, the outages. Now let's see how this model looks when risks spread through the network. This slide shows our stochastic risk propagation model. Actually, stochastic means that system has uncertainty and randomness. We cannot know the future perfectly, of course, but we can estimate the risk patterns. Predictive power refers to ability to identify potential risks before they happen. As you can see on the red curve on the slide, a small local failure can spread and create a ripple effect across the network. This helps us identify critical weak points early and prevent small failures from becoming large scale disruptions. And for the dynamic estimation, instead of just measuring uptime after crisis, this model calculates a proactive resilience score before crisis happens. This brings us to the central change of my research actually, which you can see in this comparison table. First, the temporal focus changes. Current monitoring asks what is happening right now, but our model asks what could happen next, what will happen. Second, the operational nature shifts from reactive, the fixing errors, to predictive, managing risks before it happens. And the third, the analytical method moves from just watching data telemetry to using statistical resilience estimation. And finally, the outcome goal shifts from basic uptime maintenance to resilience engineering. Why does this statistical shift matter for internet governance and, of course, the ICANN? This model is not just for engineers, it helps in three ways. For the policy support, it transforms complex system data into clear, objective facts for ICANN regulations. And for the SSR goals, it helps ICANN meet its security, stability, and resiliency goals by focusing on long-term engineering. And for the stakeholders, in ICANN's multi-stakeholders model, it creates a simple, shared language for both technical operators and non-technical policymakers. So now let's look at how we can build this framework using the tools and data ICANN already has. Our framework does not replace anything actually. It acts analytical glue to connect them. On this slide, we focus on the data we can get from three major ICANN resources. First, RSSA data. We get critical performance and stability metrics from Root Server System Advisory Committee. Second, the AAR data. We pull security data and malicious threat patterns from Domain Abuse Activity Reporting System. Third, ITHI data, we collect ecosystem wellness indicators from the Identifier Technologies Health Indicators project. Currently, these groups and tools look at isolated sectors, so our statistical framework connects all this available data together to calculate just one unified resilience score for us. After connecting these tools, who will actually benefit from this resilience scores? Of course, the whole internet community benefits. Operators can use this data for better capacity planning during heavy traffic spikes. Security teams can find weak spots and potential failure zones before an attack happens. And policymakers can make better risk-based decisions for global internet governance. To conclude my presentation today, DNS is a critical part of the global digital world. As the internet grows, resilience becomes more important. My research shows that statistical modeling can move us from a reactive posture to proactive posture. Our goal is to understand risk and support better decision making. So I want to finish my presentation with this note. We cannot manage what we do not measure, and we cannot protect what we do not understand. Thank you so much for your time.
Thank you so much, Hümay. Any questions for her? Yes, please.
Yeah, thank you. This is John Levine from the SAC. This is an interesting talk, and I'm glad it's a topic you're thinking about. But I worry a little bit about what we call the light post problem, which is that you measure what's easy to measure. And I'm thinking, for example, that there's way more domains at Cloudflare than there are in 90% of the TLDs. And there's more stuff that routes through Akamai. And your reference to Dyn was also a good example. So I'm wondering to what extent you're looking at these large sort of non-TLD DNS providers as part of your risk model. And also, and it happens that most of these companies actually have people here. I can introduce you to someone from Cloudflare if you want to talk to them.
First of all, I want to talk about the reliability theory that I want to use for this research. It's a really complex statistical thing, and we can use it for like series system, parallel system, and also complex system that contains both of them. If we can get data from different communities, we can give weights for each of them, and we can calculate this resonance scores, reliability scores for each of them and connect them together. But of course, we need data from the past and from the local or global crisis as well.
Thank you. I see another hand up.
Thank you very much. My name is Samuel Kariuki, an ICANN86 fellow for the record. My question would be, which kind of evaluation metric are you trying to measure? Is it maybe accuracy? Is it precision? Would you kindly elaborate so that we are able to understand which evaluation metric you are trying to measure in your research? I have interest in this because I'm also doing a research on the DNS attack and abuse.
So firstly, I want to talk about the reliability. Reliability is the probability that a system performs its intended function successfully over a specific period of time. And we can say it like a threshold time. And I want to also calculate the resilience for the system. And resilience is broader than reliability. It includes the ability to withstand distributions, adapt to changing conditions, and recover after failures as well. So these are the metrics that I want to calculate and find the probabilities.
Thank you. John, please.
I promised I wouldn't ask you a question, but sorry, I'm going to. John Crane, Chief Technology Officer at ICANN. I like how you're thinking. I like your approach to actually statistically measure things. I will try and read your thesis when I get back from this. One of the questions I have for you, it is important to measure things, but it's also important to measure things that then become actionable and can change behaviors. You talk a lot about things that ICANN can do, but it's important, I think, to understand how the operational side of this infrastructure works and the limits in ICANN's operational role. Now, of course, policy does have effect on how people implement things, but some of the data sets you're using, it's not 100% clear how they will relate to the resilience of the infrastructure, but that's a discussion about data sources and getting the right data sources. And I wonder how you get this methodology, not necessarily the data, but the methodology to those who actually operate the infrastructure. Yes, the Cloudflares, but also the CCTLD operators, the DNS businesses that are out there, because there are businesses that are about building this infrastructure. And I wonder if you've thought about how you take it to that next step.
Yes, this is my strategic roadmap. If I can find data from the past with ICANN communities. Firstly, I will focus on machine learning. If we want to focus on machine learning integration, first we should focus on the algorithm behind this. And for the algorithm, we need to understand the mathematical and statistical logic for it. So I will start to understand and find a really good theory for every data, and we cannot give weights for every data equally. So we cannot say every data is independent from each other. So maybe with naive Bayes or any algorithm, we should select any algorithm, or we should create an algorithm for DNS reliability. And after that, we can develop a live dashboard, and it can user friendly. Even the stakeholders, policymakers can understand this dashboard really good. And after that, I want to do empirical stress tests, and we can evaluate the infrastructure against simulated massive traffic anomalies, DDoS attacks, and systematic routing issues to validate empirical limits for our model. So everything depends on the mathematics.
I did notice there was a lot of mathematics in your thesis. So the real question then for me going forward, and we'll have lots of conversations about this, I'm sure, is how you make this actionable by the people that get that data. Giving somebody a resilience score is great. It's a good step. But the next question is, how do they decide where they want to be in those scoring parameters, and how do we help them get to where they decide their level of risk is, etc. So I think there's a lot. I like what you're doing. I think it really is thought-provoking. So thank you.
Thank you so much for feedback. As I said before, we need to look at the crisis that happened until today, and after that we can decide the threshold for it. And if we can just build a bar from green to red, I think that everyone can understand it.